At Rice, we teach freshman physics with big lectures on Monday and Wednesday, and then we break into smaller groups on Friday. And in my Friday group, I have them write whatever question they're confused about for the week, and I answer them all at the end. And I got to thinking, everybody gets confused about the same things, so maybe I should just answer them here on the YouTube channel. So what I've done is I've selected questions that I think will be useful for you to hear the answers to. You might get lots of tips and tricks about things that you're confused about that the other students are probably also confused about. So here we go, and I'm not going to say the names. What is the difference between position and displacement? And you might say, oh, that was the very first thing. Why do you not know the difference? And actually, there's a good reason to be confused about that. I kind of switched the definition on you. So if we think of this as the x-axis, and here's the origin. At first I said position is just x. It's just where you are on the x-axis. So there is a position. But displacement is a vector that represents when you go from an initial to a final. It's a change, right? That's delta x. But really, as we move on into physics, we're going to keep calling position a vector because position is a vector from the origin. So we really just think of position as the displacement from the origin to the position. So really, in a way, they're the same thing. So you are right to have them a little bit of confusion. Do we get a cheat sheet of equations on the tests? No. And if we gave you one, we probably wouldn't call it a cheat sheet. I don't understand how one can determine distance traveled and time traveled with only being given constant speed and average speed. Okay, right. So one thing is, when you think about things like average velocity, average speed, we give you these definitions that look like this. V average equals the displacement over delta t. But for most problems, kinematics problems, you're going to want to turn those around into kinematics equations. So you may remember, I think in class I said the position is the initial position plus vt, assuming you have constant velocity. This comes straight from here, right? This is x minus x naught, this is t minus 0, and this is v average velocity, but if everything is constant, you just call it v. So this is the kind of equation you would probably use. So if you're given this, you can always get the position after some time t if you know where you started, or if you went a certain distance, you can figure out how long it took. But one thing, you kind of implied that you're given neither a position nor a time. And for that, yeah, you would need one of those to solve the problem. So maybe if you look, there's more information in the problem than you think there is. If time is a measurement just as distance is a measurement, why is time not a vector like distance and position are vectors? Good question. So people often ask this. You can get into lots of very deep answers about, well, how it transforms in a coordinate transformation and it's a constant, and then in relativity it isn't, and it's part of a four vector, blah, blah, blah. There is sort of a simple answer that maybe isn't technically perfect, but that is useful at the level of physics we're doing. And that is that there is only one dimension of time. So you notice how this first section we're doing just 1D kinematics, and I keep insisting on writing vectors. And really there's no point. That's why your book, the book we use, doesn't write them as a vector. It calls it Vx along the x-axis. Okay? But I like to think of it as a vector because the vectors are coming. Soon we're going to have x and y and z, and you got to learn how to add those together, and you can only add them as vectors. Well, there's only one dimension of time. So really, there's no point in making it a vector. Anytime you add 2 times, if it's plus plus plus, you'll get a minus, and if 1 is negative, maybe you can get a negative time, which just means before what you're arbitrarily defining as the origin. It really just adds as a scalar since it's only one-dimensional. So that's why we treat time as a scalar. And then finally, I was confused about the best way to find average speed, like on the third homework problem. How do you do it? Yeah, so there was a lot of confusion about the third homework problem. I'm not going to put a video up solving the third homework problem because it's not due yet. But I think I know the basis of a lot of the confusion, and that is this idea of the average speed. So say you had a problem where you went at one speed for a while, and they're going to be uniform, so we mean really velocities, instantaneous average velocity, all the same thing. And then you went at another one for a while, and you had to get the average for the whole trip. So you know, let's call this V1 and call this V2. So hopefully you know that it's not just the average of those two. It's not V1 plus V2 divided by 2. That's not how you get the average. You could add them if you know that you have to weight them by time. You could say it's this one times its time plus this one times its time divided by the total time. That would be a time-weighted average, and that would give you the average velocity. You do not do a distance-weighted average. So say you did a problem where you went one direction for a while at one speed and then came back at a different speed. You wouldn't get the average speed by weighting them equally because they went the same distance. They went the same distance, but they took different amounts of time. It's the time that you use to weight when you're getting the average. Of course, the average velocity of this one would be 0, but it could have an average speed. So that's the main reason people are getting that one wrong, is that they are weighting them as though they are the same because they have the same distance. It's really the time that matters. But really, none of this matters because you should never do this kind of a thing to get average speed and average velocity. You should just get the total and divide it by delta t. Here, if I want the average velocity, I don't think about all this. I look right here, I look right here, I look right here, I look right here. Delta x over delta t, average velocity. Here I would say, if you're getting tricky with the distance, I'd say, okay, how far did it go on the first leg? It went up. How far did it go on the second leg? Down. So that distance times 2 divided by delta t, average speed. Don't get tricked into trying to weight them certain ways. And that's all the questions for the week.